students, welcome back to my new class. In my last video, I taught you the laws of indices or laws of exponent. Okay, this video basically I am recording for the students of class 8. Okay, so I hope that all of you have memorized all the laws of indices, because we are going to discuss today some exercises problem of law of indices or law of exponent. I will select all those problems. I will select the problems from the books of class 8. Okay, so if any class 9 students wants to watch this video, then you can watch. If your concept in class 8 was very poor, if you felt it that your concept is very poor in this chapter, then you can watch this video. Okay, so I will select some problem from class 8, book of class 8. Okay, so let's see the first problem. The first series is I have considered here some problems from the book of class 8, and the first series is find the value of each of the following. That means you have to simplify the value. The first problem is 2 cube into 2 to the power 4 by 2 to the power 5. Okay, we will solve each and every problem by using law of indices. Just remind to you, I am telling you again that law of indices only applicable, that means you can apply the laws of indices only when the base of two exponents will be same. Okay, base of two exponents is same, then you can apply the laws of indices. That means whatever you have memorized, that x to the power m into x to the power n equals to x to the power m plus n, so you can apply. If you observe that, if you observe the law properly, then you can see that x to the power m into x to the power n equals to x to the power m plus n. So in short, you can memorize this. In short, you can memorize these laws by, in the case of multiplication, you have to keep in your mind that always we need that each and every exponent are having same base. Then you can apply the rule of exponent or rule of indices. So see here, x to the power m, x to the power n. For the first indices, for the first exponent, base is x, and for the second one, base also x. So this is called base and this is called power, x to the power m. In this exponent number x is called base and n is called power or index or degree. Okay, three names. So x to the power m into x to the power n, since these two are having same base, so we can add the power. So in the case of multiplication, you have to add the power, and in the case of division, you have to subtract the power. In short note, you can memorize in this way. Is it clear? If base are same, then in the case of multiplication, we have to add the power, and the case of division, we have to subtract the power. Hope you understand. Next, see the first one. I am solving the first solution. First one is there, 2 cube into 2 to the power 4 by 2 to the power 5. You can use by the basic concept of exponent. Okay, but we will use here the laws of exponent, since we have to have habituated with this. Okay, so equals to, we can write, since 2 to the power 3, this is an exponent number or in power form, and 2 to the power 4 also another exponent number, and both of the exponent number having base 2. See, 2 to the power 3, here base is 2 and 3 is power, and for the second one, 2 to the power 4, 2 is base and power is 4, so 2 and 2 same. Okay, so since multiplication is there, so we have to add the power. So in numerator, we can write 2 to the power 3 plus 4 by this law, and in denominator 2 to the power 5. Okay, equals to, the numerator is 2 to the power 3 plus 4 means what? 7 by 2 to the power 5. Again, in numerator and denominator, they are having two exponent numbers, and in numerator the base is 2 and for the denominator also base is 2, so we can subtract the power. Just try to remind the one more rule, that x to the power n by, remind this law, that x to the power m by x to the power n equals to x to the power m minus n. Can you remind this law of indices? Okay, so you have to use this one. This is x to the power m by x to the power n. X same thing. So in the case of division we have to subtract the power. So I am subtracting the power, so it will become 2 to the power 7 minus 5. Okay, 2 to the power 7 minus 5. 2 to the power 7 minus 5 means what? 2 to the power 7 minus 5 means 2 to the power 7 minus 5 means 2. Now put the value. 2 square means 4. So this is the answer. Hope you understand how to solve or how to apply the laws of indices. Understood? Always you will try to apply laws of indices. Then easily you will get the answer. Hope you understood the first one. Please note down. Okay, next, second one. So first one done, next second one. For the second one, it is given that minus 2 to the power 3, that means minus 2 cube into minus 3 square by 6 square. So you have to wait for a few minutes. Okay, second problem. See, minus 2 whole cube into minus 3 square by 6 square. Okay, since the first one is base is minus 2 and for the second one base is minus 3, so we could not apply the law of indices. So what we will do? We will expand it. So minus 2 cube means, minus cube means we have to multiply minus into minus into minus. We know minus into minus means plus, and minus into minus into minus. If we multiply these three, then these two minus, minus into minus plus, and plus into minus, again minus. So if we multiply odd time negative, that means odd time of minus, then it itself again minus, and if we multiply even time minus, then it will become positive. So minus cube means minus and 2 cube means 8 into minus square means it will be positive and 3 square means 9 by 6 square means 36. Now cancel, then 9 into 4 and 4 by 4 this 2. So it will be minus 2. This is the answer. We could not apply here the law of indices. Without apply the law of indices, I have solved this problem. You can solve this problem by using law of indices also. This is alternate method. Alternate method. What? In the place of minus 2 cube is there, so you can keep it unchanged, and minus 3 is there. So, okay, leave it. No need to solve it again. Next. So, second problem is done. Next. Fifth number problem. This number problem, fifth. For fifth number problem, 3 by 2 to the power 5 into 3 by 4 to the power minus 2 is there. So we know that 3 by 2 to the power 5 equals to 3 to the power 5 we know 3 by 2 to the power 5 means we can distribute the power over numerator and denominator. If we distribute the power over numerator, then it will be 3 to the power 5, and if we distribute this power in denominator, then it will be 2 to the power 5. So 3 to the power 5 by 2 to the power 5 into 3 by 4. Okay, 3 by 4. This again power is minus 2. So we can solve in very many different way. Okay, so I am distributing the power over numerator and denominator, then it will be 3 to the power minus 2 by 4 to the power minus 2. Understood? And next line, keep it unchanged, 3 to the power minus 2. Okay, see, here 3 to the power 5 is there, here 3 to the power minus 2 is there, and product is there. So since base are same for these two exponent numbers, so we can add the power. So the numerator will become 5 plus of the second power minus 2. Understood? And for denominator 2 to the power 5, now we'll express, since here base is 2 and for the second exponent base is 4, so we will convert this base 4 into the base 2. So is it possible? Possible. Why? In the place of 4 we can write 2 square. See, I am writing in the place of 4 2 square. So I have written 2 square in the place of 4. After that minus 2 was there, so whole power will be minus 2. Understood? This is the 4. 2 square means 4. 4 to the minus 2 was there, so in the place of 4 we have written here 2 square. Next, solve the numerator, that is 3 to the 5. This is nothing but 3 to the power 5 and plus minus 2 by 2 to the power 5 into 2 to the power. I told you that inside the bracket and outside the bracket if power is there, then we can multiply these two power. So if you multiply this power and this power, then it will be 2 to the 4 and sign will be minus. So 2 to the power minus 4. Understood? Equals to, in numerator it is 3 to the power 5 minus 2 means 3 by 2 to the power, here base are same, so we have to, and multiplication is there, so we have to add the power. So 5 plus of minus 4, that means minus 4 itself. Okay, like this part, plus of minus 2, so there will be also 5 plus of minus 4, that means this. So this is nothing but 3 cube by 2 to the 5 minus 4 means 2 to the 1. 2 to the 5 minus 4 means 2 to the 1. So 2 to the 1 means 2 itself. So 3 cube means 3 3s are 9 and 3 9s are 3 cube means what? 3 times multiplication of 3. This, so 3 into 3, 9, 9 into 3, 27. So 27 by 2, this is the answer. Hope you understand this solution. Okay, next sixth number problem. Next, this solution. 3 square means 3 into 3, that means 9, plus 3 to the minus 2. We might just remind one law of indices, that x to the minus m can be written as 1 by x to the power m. So x to the power minus 2 can be written as 1 by x square. So just for this minus, we have to consider this term in denominator and this negative will be positive. So 2 to the power minus 5 can be written as 1 by 2 to the power 5. So these are the example. So in the place of 3 to the power minus 2, you can write 1 by 3 square. And what is the value of 3 to the power 0? For any number, any non-zero number, if power is 0, then the value is 1. This is the law of indices. So 9 plus 1 means 10 plus 1 by 3 square means 9. Now take LCM. LCM will be 9 and it will be 90 plus 1 equals to 91 by 9. Understood? So this is the solution. Two series. Okay. Read the question, simplify and give the answer in positive index. Okay. You have to give the answer in positive index. So what is positive index? This is the question. Positive index means, suppose I am discussing about positive index only. Okay. Suppose you have 2 to the power 5. Okay. Then here 2 is called the number, this 2 is called base and the number, this file is called index or power or degree also sometimes, degree. So you have to keep this number as positive. Suppose in 2 to the power 5 the index is 5, index is 5 here and 5 is positive, but if you consider 3 to the power minus 2, then here base is 3 and index is minus 2. So you have to convert the power minus 2. Since here index is negative, so you have to keep the answer, see, give the answer in positive index. So you have to convert it into a positive index. So how can we convert? Just remind that identities, remind a law that x to the power minus m, here index is negative, see, minus m is index, it is negative and it can be written as 1 by x to the power m. So we have to use this rule. Understood? Okay. So next I am solving the first problem. Choose one. Look at the code. Solution. Choose one. It is given that a to the power minus 2 into b to the power minus 3 into c square by b to the power minus 4 into c to the power minus 3. Okay, so first we will try to apply the law of indices. Okay, see, here a is given, b, the exponent for the second number base is b and exponent for third one base is c, and denominator here one more exponent is there, base b. So if you consider this exponent and this exponent, then these two are having same base, so I can use the law of exponent, and here division is there. So in the case of division, we know that power should be subtracted. So apply, and c same, so keep a to the power minus 2 unchanged, and if we consider this b and b, then b to the power minus 3 was there, and we have to subtract the power of this. B to the power minus 3 was there, and we have to subtract this power just from that rule that x to the power m by x to the power n will be x to the power m minus n. We have to apply this one, that we have to subtract the power from the numerator x to the power m minus n. See, x to the power m minus n. So it will be b to the power minus 3 by b to the power minus 4. That means b to the power minus 3 minus of the power of denominator. Power of denominator is minus 4. Hope you understand this thing. And for c, similarly for c, 2 is there and in denominator minus 3. So 2 minus of minus 3. So I have applied the law of indices. Now simplify it. If you simplify, then it will be a to the power minus 2. And if you simplify the power of b, then minus 3 and minus minus, it will become plus 4. So minus 3 plus 4 means, actually if you simplify this part, then it will be plus 4. So minus 3 plus 4 means plus 1. Plus 1 means b, power of b will be 1. Okay, dot. 1 means you can keep it empty. C to the power 2 minus minus plus 3. 2 plus 3 means 5. So is this the answer? No. Read the question. Give the answer in positive index. So here index of b is 1 positive, and index of c is 5 positive, but index of a is negative. So we have to convert this index into positive. So in the place of a to the power minus 2, we can write 1 by a square, as I discussed in beginning of this problem, before solving this problem. So a to the power minus 2, in the place of a to the power minus 2, it can be written as a square. Okay, into b, this term, into c to the power 5. So now multiply the numerator, then in numerator this term are, so b c to the power 5 by a square. Now this completes the solution. Hope you understand. Next, problem number 2. This is problem number 3. I am solving. Note down this all part. Twos, 3. 3 is given 4a square bc whole cube by 6ab square c whole square. Just remind one thing, I have told you that if outside of the first bracket a power is given, then we can distribute the power over all the factors of the term which is in first bracket. If a plus b is there, a plus b whole to the power 2, it does not mean that you can distribute the power over all the terms. Why? Since addition is there. If inside the bracket they are in multiplicative form, then you can distribute the power. In the case of addition or subtraction, you could not. This is not equals to, this is wrong. This is wrong. You could not distribute in the case of addition, but in the case of multiplication you can. So see here, in the case of multiplication and division you can. So here all the terms are in multiplication, so if we distribute over all the factors, that's why I am using factors, that means are in product form. Okay, 4 cube, first we have to use 4 cube. 4 cube means 4 into 4 into 4. So 4 4 is 16, 16 into 4, 64. So it is 64. Now a square, then cube, a square, after that cube. So I told you that we can multiply this power, so it will become a to the power 6. Next b cube, next c cube. So this is the numerator, and denominator will be 6 square is 36, a square, b square, and then again square. So if you multiply these two, so b to the power 4 into c square. Clear? You can cancel out over numerator and denominator. You have used that already, but since we are solving now the law of indices, actually the cancellation also follows by the law of indices. Okay, so you can cancel also. So if we apply the law of indices, then first try to cancel the numeric part. Is it possible to cancel it? Yeah. Four cancel by 4, then 4 16s are 4 9s are. So 16 by 9. This is the numeric part. So equals to 16 by 9 is numeric part. Now we will solve. See here, a to the power 6 is there and a square is there. So these two are in division form. So and they are of same base. So we can apply the law of indices. So you have to subtract the power. So a to the power 6 minus 2. Okay, a to the power 6 minus 2 means, a to the power 6 minus 2 means 4. Next, b cube and b to the power 4. Also base are same. So we can use the law of indices. So it will be become b to the power 3 minus 4. In the case of division, we have to subtract the power. So b to the power 3, b to the power 3 minus 4. So 3 minus 4 means minus 1. So this is b to the power minus 1. I am solving directly, okay? And it will be c to the power 3 minus 2. That means 1. 1 means we can keep it as 0. Now is it the solution? No. According to the question, you have to give the answer in positive index. Check all the index are positive here or not? No. The index of b is negative here. So you have to convert this index into positive. So you can write here 16, a to the power 4 already in positive index, c also positive index, and in the place of b to the power minus 1, we can write b to the power minus 1, we can write 1 by b to the power 1. So b to the power 1 means b only. So in the place of b inverse, we can write 1 by b. So in the place of b, if we write 1 by b, then this b will come in denominator. So I am writing here. So this is the answer. Hope you understand the solution. Understood? Next, problem number 4. I have to solve now problem number 4. The first one we have done. Okay. Note down all the solutions. Okay. Next, choose 4. What is given here? A by BC square to the power minus 3 divided by BC by A square whole to the power minus 2. This. So, as I told that in the case of division, we can distribute the power over numerator and denominator. So it will become a to the power minus 3 by BC square to the power minus 3. Division is there. So BC to the power minus 2 by A square to the power minus 2. Next step will be a to the power minus 3. Again apply the law of indices. Multiplication form is there, and outside of the first bracket a power is there. So we have to multiply, we can distribute over all the factors. So if we distribute over b, then it will be b to the power minus 3. And if we distribute to c to the power minus 2, then we can multiply these two, so it will become c to the power minus 6. Okay, division is there. Next, it will be b to the power minus 2, c to the power minus 2 by a to the power, we can multiply these two, minus 4. Did you get it? Okay. Next line I am solving on this side. Equals to okay, first fraction keep it unchanged, e to the power minus 3 by b to the power minus 3 into c to the power minus 6. In the place of division, we will use here cross. Okay, so if we use here cross, then we have to consider the reciprocal of the second fraction. That means numerator will go to denominator, and denominator will actually we have to interchange the numerator and denominator. You know this concept that 2 by 3 divided by 5 by 7. Then 2 by 3 in the place of division we are write multiplication, and 5 by 7 changes to 7 by 5. Okay, we are using the same concept here. So it will be a to the power minus 4 by b to the power minus 2 into c to the power minus 2. Yes, this equals to, see here in numerator e to the power minus 3 cross e to the power minus 4. So two exponents, these two exponents having same base a, so we can, since multiplication is there, so we can add the power. So if we add the power, then x to the power a to the power minus 3 plus of minus 4. That means plus of minus 4 means plus of minus 4. This is nothing but plus minus of minus 4 only. So minus 4 by, in denominator, b to the power minus 3 into c to the power minus 6, into is there, b to the power minus 6 into c to the power minus 6. So for this b and this b, these two are having same base, so we can use that rule again, minus 3 minus 2. We have added here, okay, but plus of minus 2, that is why minus 2. And for the case of c, it will be c of minus 6 minus 2. A similar manner. Now simplify. In numerator, it is a to the power minus 7. In denominator, b to the power minus 5 into c to the power minus 6 minus 2 means minus 8. So it is in negative power. Okay. So you have to convert this power into the positive form. Just change the position. That means if a term is in negative form in numerator, then take it in denominator, then automatically it will change the power. So a to the minus 7 is in numerator, so if you consider this term in denominator, then it will be a to the 7, and b to the minus 5 is there. So if we write b to the 5 in numerator, then it will change. So these two terms are negative, so if we consider this term in numerator, then it will be b to the 5 and c to the power 8. Okay, and this a to the power 7 considered in denominator, then it will be a to the power 7. I have applied the sort trick. Okay, so now all the index are in positive, so this is the answer. Hope you understood all the solution. Next, if x equals to, okay, three series, I am given that if x equals to minus 2, y equals to minus 3 and z equals to 1, then find the value of x plus y plus z whole to the power x. And the fourth problem is x to the power y into y to the power z into z to the power x. Okay, you have to find out the value of these two. I am solving the first one. Directly we will put the value. Okay, given that x equals to minus 2, y equals to 3, z equals to 1, then to solve the first one, x plus y plus z to the power x equals to put the direct value. X equals to minus 2, in the place of y it will be 3, plus in the place of z 1, whole to the power x means minus 2. Now simplify the value of first bracket. If we simplify the positive only, then 3 plus 1 4, 4 minus 2, 4 minus 2 means 2 only, so 2 to the power minus 2. Okay, 2 to the power minus 2 means 1 by 2 to the power 2. Just I have discussed in my previous problem. 1 by 2 to the power 2 means 1 by 2 square means 4. So this complete the solution. Okay, this is the first one. Next, second one. Fourth one. I am solving here. Okay. Second one you have to solve one. That means fourth one. X to the power y into y to the power z into z to the power x. Now put the values. X equals to what? X equals to minus 2. The power of minus x is y. So y is 3. So put here y means 3 into the power is z means 1 into z means 1 and power is x means minus 2. Now simplify. Minus 2 cube. Minus cube means minus. Minus into minus into minus, and 2 cube means 8. Dot. 3 power 1 means 3 itself, and 1 power minus 2 means 1 by 1 to 1 square. 1 is actually power of 1, whatever power of 1 is there, ultimate value will come 1. Okay, so 1 by 1 square means 1 itself. So 3 into 8 into 1 means minus 24. This complete the solution. Hope you understand all this thing. Okay, next we will solve fourth series. Fourth series is given. Express the following. 3 6 0 0. Okay. Next, see the fourth series. Express the following in exponential notation where base are prime number. Where base are prime number means you have to express the as I told you in my first video that 64, suppose this is a number, we can express this number into different form. How? 8 square, that means 8 into 8 means 64. You can use 4 cube, that means 4 into 4 into 4, also 64. And also you can write 2 to the power 6 also. Here base is 8, which is not a prime number. 8 is not a prime number since 8 can be divided by 2 and 4. Here 4 is 4 cube, this is also another exponent form, but here base is 4 and it is not a prime number. Why? 4 can be divided by 2. This is another exponent form of 64 where base is 2 and obviously 2 is a prime number. Okay, so you have to express all this number into the form of exponent where base should be prime. Okay, so how can we solve? Just we have to consider the factorization process. Okay, solution of first one. For the first one, here numerator and denominator is there. Okay, so numerator, just expand the numerator, then by 2 it will be 4, by 2 again 4, 2, so 8 can be written as 2 into 2 into 2, that means this is nothing but 2 cube. So in the place of numerator we can write 2 cube, so it converted the numerator into exponent form. Now for denominator, again factorize the denominator, 3 4 3. First we have to divide by 7. Okay, so 7 means 7 is 7 4s are 28, then 28 gone, so there is 6 and 3 63, 7 9s are 63. Now by 7 into 7, so 3 4 3 can be written as 7 into 7 into 7. This is nothing but 7 cube. So in the place of 343 you can write 7 cube. So this is nothing but 2 by 7 whole to the power 3. We can use this notation. Why? Since outside the first bracket we can write the 3, then this 3 will distribute over numerator and denominator. So this complete the first solution. Okay. If there is different power, then you could not use this notation. Suppose there is 2 to the power 3 by 7 to the power 4. Instead of 3, if there is any other number, then you could not use this notation. Then it is impossible to express into a single. What will we write here? 3, then power of 7 will be 3. 4, then power of 2 will be 4. So we have to keep there only. Okay. So this solves the first solution. Second one. See the second one. Sorry, fourth one. For fourth one, you have to factorize 33600. So 3360.
Please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.